So hello everyone, I'm Bhavan Gain and today I'll be presenting some summary of the lectures, and then I'll provide some examples for solving the assignments. So let's wait for a few minutes to let other joins. Okay, so in this session, I'll be covering some what is linear regression and some how to how what is the need of that and things like that. And after that, we'll go to some numerical problems and we'll solve the problems. And I'll mostly covering the numerical problems only. The conceptual questions I think you can solve by watching the lectures. Okay, so let's start from logistic regression. So what happens? Any query? Okay. So, what is logistic regression and how it is different from linear regression? So, in linear regression, as you can remember,
Sir,
yeah, hello.
can you explain that linear classification part where sir explains that the expected value of y for a given x is equal to the probability of x for a given k?
Can you repeat?
Like sir draws a graph,
Mhm.
and there he shows that expected value of y for a given x is equal to the probability uh, that the class is k for a given x. Like
Okay.
when he draws up a conclusion from the linear regression part, x
Mhm.
transpose x whole inverse x transpose y.
Mhm.
From there he shows up that the mean of the expected value, so all those things.
Mm, okay, I'll try to check the lecture. So, can you point out any time frame here?
Yeah, so maybe towards the last maybe the 11th minute somewhere.
Is it here?
Yeah, this. So at towards the last he then draws up.
Yeah.
Actually, I was not able to get that beta cap also, the matrix.
This one.
Yeah, the beta cap matrix.
Okay, so I think you can understand it via the diagram. So here.
So actually, I couldn't get that why this linear regression, this thing x transpose x, which has been derived during the linear regression lecture, is
Mhm.
now used in this classification.
Okay, so suppose in linear regression, what you do is that you have a number and you kind of try to predict the number, right? So maybe depending upon how much hours did you study, you are trying to predict the marks. Okay, so that is kind of
Yes.
we can say linear regression. And classification, you can formulate the same thing depending upon how much hours you have studied, you are trying to make a prediction that whether you will pass or fail. Okay,
Yes, sir.
so that is kind of a linear say classification.
Okay, sir.
Yeah. So here you can see like there are multiple points here, okay, and like we have to draw a line in such a way like it will be able to divide those classes.
Okay, sir.
So like here so always it may not be possible, so maybe it is possible that suppose if we are considering uh, okay, let me draw a diagram on here myself. Okay, so like it is also possible that some people will be uh, some people will kind of a pass with very few hours of study, and it is also possible some people will pass like we will fail after, even after studying a very long hours. So let me show something.
Yes.
Okay, I hope new whiteboard is visible now. So I'll just quickly draw. Suppose this is the graph, and here we have hours of study, and here we'll have like pass or fail. Pass means suppose a triangle, and fail means suppose a circle. Okay, so this is like 1 hour, this is like 10 hour, okay, and 0 here means like here means fail, and this is like pass. Okay,
Yes.
so then suppose someone studied 10 hours, he passed, another studied 9 hours, he passed, another like this one like they passed actually. So here like pass everything. Some people here failed, okay, here failed. Then it is also possible some people studied for like 10 hours but still they failed, like 10, not 10, like say 6 hours, then they failed. Some people 12 hours also, then they failed. Here also some people studied very less hours, then also they kind of say they fail, they failed, yeah, they passed. Okay, so we have to draw a line in such a way so that like we are able to divide. Okay, so suppose if we draw a line like this, okay, so that means say not this, okay, like this. So here it means that suppose there is some point, okay, uh, so if you study more than that hour, it is very likely that you will pass, and if you study less likely more less than that, then that means you are more likely to fail. So basically this line represents that like if it is if you are studying something, so suppose you are studying at this, okay, like this suppose 10 hour and 10 is like this, so that means you have kind of a say 0.8% chance that you will pass, this kind of thing. Similarly here, like if you study say 2-3 hours, then like only 0.2% chance that you will pass, means you are actually failing. So all that is what linear classification do. So basically the main thing is drawn by a line, and it is very similar to the linear regression, because linear regression also tries to predict a number, but here the number is the we can say we are basically classifying this and this based on the line. So is it clear now?
Yes, sir.
Okay. So I'll move on to the logistic regression. So in the logistic regression, we basically try to predict the probability of an event, and same we can apply here, like the pass fail thing. So what is the problem with linear regression, and why do we need logistic regression? So there are many reasons to do that. So main two reasons are that interpretability. So if we kind of say that in the linear regression we do not have any interpretability, so we don't know that if we kind of say increase the number of hours of study, how much that will improve in our result. And it is also so with logistic regression we can do it more easily. I'll discuss how. And then handling of outliers. So outliers means some of the data points which are not where it is expected. So suppose I am saying there in this, so you know here he is supposed to be fail, he is supposed to be pass because he is studied much more hours, but he is actually failing. So that is, we can say, kind of an outlier. It is not where it is kind of expected. So with with logistic regression we can handle this kind of things more easily. So I'll give you an example. Suppose this is a kind of a tumor size, and the objective is that we have to find out if it is malignant. So this means that is it dangerous. So if the tumor size is very small, it is not really dangerous, and if it is large, then it is dangerous. So this is, we can say, linear classification. Okay, and what we are doing is that we are dividing a line here, and this is the kind of a say having equal distance from all this. So we can say that if the tumor size is more than this, then it is malignant, and if it is lesser than this, then it is, we can say, like, no, it is not dangerous. Okay, but what happens what happens if we add an outlier? So suppose there are 4 here, 4 here, but suppose there is someone with very large amount, like very large size of tumor, okay, this in the data set. So we have to kind of adjust the linear regression, like regression line accordingly, right? So the line will be like this, okay, to kind of accommodate this also. And what happens if the line is this? So you know the line is getting skewed toward this, and this like level 1, okay. So because of that we can say that linear classification is, so just adding a, using a linear line is not really helpful in this case, okay. So what if we can fit these things like this, so that will be more appropriate for this case. So that is why we are using logistic regression. So suppose here with linear regression we are drawing line like this, but with logistic regression we are drawing line like S-shaped line. So you know this line is actually covering those data points very like appropriately, very near, the line is passing very near to those plots. So that is basically the logistic regression. So I have provided some link also, so you can learn more on those links. So how do we get logistic regression? So do you remember that linear regression, this is the formula for linear regression. So beta 0 plus beta 1 x, if we calculate those, we will get the prediction y. So this is for linear regression, but in this case what we are doing, we are trying to get some value, get some probability of
Please, can you explain the green and blue line in the last image?
okay. So here a blue line means, here you focus at here, blue line means that if uh, say suppose you have a new point and the tumor size is like, say suppose here, so you will look at the this line and say that this line is above blue line, so it is 1. And suppose a new tumor is here, size is this, you look at this and say that this is above blue line, this is below blue line, so it is not its level is 0, okay. But in this case when we are adjusting the line, you see that this one is the new line, okay. So this is around 0.2. So here suppose at this point, okay, so at this point we are getting a level, after this point we are getting level equal to 1, but here you know the point is much lower. So even if the tumor size is much lesser, okay, we are still giving 1 level. So that is kind of getting biased towards like level 1. So that is the problem with linear classification. Is it clear?
That once again.
Yeah. So okay, so here you can see this line, I mean here it is 0, here it is 1, in the middle it is 0.5, okay. So when we have this line for the classifier, so this is basically like linear classification line. Okay, so when we are having this line and we have a new tumor, suppose here, okay, and then we have to see that is this below the this line or above this line. So if we look at this point, and if we go above this is below the blue line. Okay, so that means it is not malignant. So this is, we can say that this is not dangerous tumor. Okay, but suppose here the line is changed because like after this point. Okay, so after changing this line, this is the new line, and suppose we have the same we have the same tumor. Okay, uh, at this point, suppose, and what will happen if we check the green line is actually above than the like above the yellow line. So in this case we can say that the tumor, we are saying that it is not dangerous, but in this case for the same size we are saying that the tumor is dangerous. Why? Because of this, because of this point the like line got extended, and because of that this point, initially the classification boundary was this. So above this it was, we can say above this it was a positive, and below this it was negative, but here now above this it is positive, above this it is negative, like above, below this it is 0. So in this case model is not really able to classify properly. So even for say non-dangerous tumors it is saying dangerous. So that is the issue with linear classification, and because of that, say in case of, because of one outlier, we can see this issue is happening. So with logistic regression, if we feed by this kind of thing, so even if suppose there is some point here, we can just extend this, right? So it will not affect these things. So that is the like advantage with logistic regression. Is it clear?
Okay, sir. Thank you.
Yeah. So basically in logistic regression we are estimating the probabilities, and but what will happen in linear regression? So suppose we are trying to predict a number, it can go below 0, like it can go also go like above 1. So to handle that, we are doing one thing. We are taking probability of some class divided by 1 minus probability of some class. So basically instead of y equal to beta 0 plus beta 1x, we are basically trying to get the odds. Odds means that what is the probability of happening something divided by what is the probability of not happening something. Okay. So suppose okay.
Sir, here P of some class means this is the predicted class, right?
Yes, yes, right. So basically suppose in the example we are trying to find that if he has a dangerous tumor or not dangerous tumors. Okay, so it's kind of like that, or maybe like you can say passing and not passing, so failing, and we are trying to build a model which will give the odds, like what is the probability of passing divided by what is the probability of not passing. So we'll the model will give that as the output. But if we do that, what is the problem? The range is 0 to infinity, right? Because you know p, this is probability, it will not go below say 0, but maybe passing probability is 0.9 and failing probability is suppose 0.1. So if we divide, that is kind of say 9. So it can go, so if the probability is very high and this is very low, it can go very large amount. So but in the left hand side we get 0, because you know if we are taking probability, the maximum, the minimum that we can get is 0, like p by 1 by p. So if we say p equal to 0 and this is 1 minus 0, so in that case we are getting 0. So it cannot go below 0, and that is problematic because this is kind of restricted, right? So because like we are trying to restrict a model to not predict some in that range below 0. So that is actually a very hard problem, and it is difficult to formulate to for a model to kind of restrict. If we are restricting it in some range, then it will it will not be very correlated. So because of that, what can we do? We can take log of that, log of p divided by 1 minus p. And so basically what we are doing here is that we are training a model, and the model will give the log probability of p divided by 1 minus p. So in the linear regression we have this, we are telling the model to predict y. In the logistic regression we are telling the model to predict log p divided by 1 minus p, so value of this. Okay, so this is the basically the formula of like logistic regression. And suppose we are taking the exponential on the both sides. Okay, so exponential, then log, and then this is then exponential of this. Fine. So we know exponential and log, if we combine, then it is like just 1, it is nothing. Okay, so it is these two gets cancelled, so p divided by 1 minus p here, and e to the power beta 0 plus beta 1 x, so here. So after that what we do, why we actually multiply 1 minus p here, because it is division here, and if we go on to the RHS it will be multiplied. So 1 into e, so this is e, and up like power is the same, then minus p into e, so pe, and power is the same. Okay, so till this I hope it is clear. Then we are basically moving this part minus p to the power this thing to LHS. So what will happen? P plus p b to the power 0 plus like beta 0 plus beta 1 x. Okay, so if we take the p common, then it will be p common 1 here plus here p we have taken common, and e this one beta 0 plus beta 1 x, and in the RHS we are keeping this same. Okay, so what is p then? This one is already there, and if we just move this part 1 plus e to the power beta 0 plus beta 1 x, if we shift this to the power this to the RHS, it will be like value of the p. So this one is already there, and this one we are like just dividing from the LHS. So this is the formula to get the p value. Okay, and then if we divide this by e to the power b beta 0 plus beta 1 x, so here if we divide this also and this also both like numerator and denominator by the same value, then what will be the value? If we divide this by this, value will be 1. Okay, if we divide this by this one, then value will be e to the power minus of beta 0 plus beta 1 x, because you know 1 by something is like basically the minus if we consider in terms of power, and here this one divided by this one only, so this is 1. So like numerator and denominator will be same here, so the value will be 1. So this is the value of the p equal to 1 divided by 1 plus c to the power negative beta 0 plus beta 1 x. So this is we can say the sigmoid function. Okay, so this is basically what we try to estimate in the linear regression, in the logistic regression. So in the like assignments you have some numerical questions, and I'll try to solve those here. So these are the some additional formulas that are actually present in the in the lectures only. So this is basically, if we want to find a likelihood, this is the formula. So this is the prediction sigma into the theta transpose and xi. So this is basically the prediction to the power y, and 1 minus the prediction by the like logistic regression model, and to the power 1 minus y, and this is just the log likelihood. Okay, so if you like need those in assignments, you can use those, but I hope this first equation will be sufficient. So okay, I'll come to the first equation, first question later, because this is about the PCA, this is about LDA. Okay. Okay, so let's move on to the second question, third question. Okay, let's go to the likelihood, fourth question. So you are given p of x. So this is the basically the output from the model, output from the logistic regression model, and you have the y. Y means like the actual value, the label what is given in the data set. So in this question, you are given the labels, you are given the output, and you have to find the likelihood. So how to find it? You know, this is the likelihood formula. So you have to multiply p to the power yi and then 1 minus p to the power 1 minus yi. So suppose for the first data point, what is the p here? P of x is 0.1, and what is the yi? So yi here is 0, right? So 0.1 to the power 0, fine. Then 1 minus p means 1 minus 1 0.1, that is 0.9. Then 1 minus yi, so 1 minus yi is 0, so 1 minus 0 is 1. Okay, so 0.9 to the power 1. Similarly here it is p of yi, which is 0.8 to the power p of yi. So like this is p to the power yi, so yi is 1, so 0.1 power 1, then 1 minus 0.8, which is 0.2, and 1 minus 1, which is 0. Similarly here also 0.9 power 1, and then 1 minus 0.9, which is 0.1 power 0. Okay. So if we calculate this 0 to the 0.1 to the power 0, which is 1, and 0.9 into power 1 is 0.9. Okay. So here we are getting 0.9 only. Similarly here we are getting 0.8, and similarly here we are getting 0.9. So if we multiply all of them, the final value is 0.6648. So this is the likelihood of these points of the like by the model. Okay. So the model is predicting this value, and the actual values are this, and from this we are finding the likelihood, and the likelihood value is 0.648. So is this problem clear to everyone? So please let me know if you have any confusions regarding this solution. So in the assignments there are similar kind of problems. So if you kind of apply this formula, so I think you can solve the problems. Obviously the numbers, I have changed the numbers. Then let's go to the next point. So in this case we have like two values. We already given the output from the model, but here we are given the input only, like the data only, not the model prediction. Okay, and we have to kind of find model prediction, and then we have to find the likelihood. So for the model prediction, for the likelihood, we need two things. We need the model prediction, and we need the label. Okay, and then we have to kind of find what is the suitable beta 0, beta 1, beta 2, so that the likelihood is the highest. So in this case we have 2 points, 0.5 and point minus 4, and level is 1, 0.6 minus 0.6, level is 1, and minus 0.8, 0.5, level is 0. So in this case I will try to solve this on programmatically. So I have already prepared a kind of say document, a code for that. So basically what we are trying to do here is that you can also like do it by hand. Okay, so for like faster calculation I have used like written a Python code, but you can do it on your hand, and it is better to do it in your hand because it will be better for your exams. In the exams, like you will not be able to write programs. Okay, so in this case what you need to do is that at first we need to find p of xi, right? So p of xi means, suppose we have values beta 0, beta 1, and beta 2. Okay, so given beta 0, beta 1, and beta 2, we have to find the value of pxi. So what is the output of the model, and when we get the output of the model, then we can find the likelihood if we compare with y, right. So here we are writing the function. So import numpy as an np. So this is basically a library for matrix calculation. You can this library is very popular for very numerous mathematical operation. So this is the main function. So I hope it is okay. Let me zoom it a little bit. Okay. So basically we are trying to calculate p of xi, because here we are calculating pi xi is given p of x, and by that we are able to calculate the say likelihood, and here we are given x only, not p of x. So we are trying to calculate this. So how to calculate p of xi? With this formula. So let's take one step at a time. Let's calculate this part one, beta 0 plus beta 1 xi plus beta 2 x2. Okay. And what is the value of beta 0, beta 1, beta 2? This can be from this it can be this one, it can be this one. So we'll iterate through all of them and find out which one is better. So let's get to the function. So we have the value of betas. So by betas means we have three numbers, beta 0, beta 1 and beta 2, and we have values of x. X is like x0, like x1 and x2. So x1, this one is the x1. So index starts from 0. So that is why this one is x1 and this one is x2. Okay. So we are in this case we are finding what? We are finding beta 0 plus beta 1 x1 plus beta 2 x2. So we are calculating this part, beta 0 plus beta 1 x1 plus beta 2 x2, this part. So after calculating this, what we need to do? We need to find 1 divided by 1 plus e to the power minus that value, right. So 1 divided by 1 plus e to the power minus of that value we obtained from here, right. So this function will calculate the p of xi, the prediction given the beta and given the x, right. So let's go there. So this is the point. Okay, data is 0.5 minus 0.4. So we have already defined the data 0.5 minus 0.4, 6 minus 0.6 and minus 8 minus 0.8 and 0.05. So I have just written those in this format, data format. This is kind of list of list. So this one x1 x2 x1 x2 x1 x2, and there are three numbers, like three data points. And what is the y? Y labels are 1 1 and 0, right. 1 1 0. So this is the values. Okay. Then what we are doing for x in data? So we are iterating through all of these like one at a time. At first you are taking this, then we will take this second one, and then it will take this. We are taking this, and then we are calculating p of xi. So what is the beta value here? In the first option we have the beta value of 0.5, 1 and 2. So we are using the same beta value 0.5, 1, 2, and we are calculating the p of xi. So basically let me run this code. Basically here yes, we are calculating the p of xi here. Then after that, after calculating the p of xi, we are getting these three values. Okay, 0.5498. So this one is for first one. So basically here we have x1 x2, and for that with these beta values we are getting the p of xi value for the first row. For the first data point is this, for the second data point is this, and for the third data point it is this. So we have got the p of xi value, and we also have the y value, right. So y value here we have the y value here already given in the data, and from the model we are getting this value, right. So from that we can calculate the likelihood. How to calculate the likelihood? We have the y hat. Y hat means basically here p of xi, which is the prediction from the model, and y is the label. So basically we'll just apply this formula here, this formula. Okay, so because it's a multiplication, we are starting with 1, then we are iterating through all the data. So basically we will go through the first row, like first data, second data, third data, and within all the data we will calculate y hat power y. So this is basically here p of, this is we are calling y hat. So here y hat power y, then 1 minus y hat minus 1 minus y. So this is the what is written here, y hat, this is power y into 1 minus y hat power 1 minus y, and for like after calculating with all the points in the data, we are just returning the result. Okay, so this is the two functions that you are using. So basically we have defined the data here, we have set the beta values here. So after that, when we have set the beta value, we will calculate the p of xi. So after calculating the p of xi, the p of xi values are this, and y hat are like y value is 1 1 0, and if we calculate the likelihood is coming to be this. Okay, so this is for the first option. For the first option, beta 0 equal to 0.5, beta 1 equal to 1, and beta 2 equal to 2. For this value, the likelihood is coming out to be 0.86. Then let's move on to the next beta values. So in the second option, the beta values are minus 0.5, minus 1 and 2. Okay, and if we calculate the like model prediction from that, it is coming out to be here 0.14. So this for the first data point, the prediction is 0.14. For the second point, the prediction is 0.9, and for the third point, the prediction is 0.78, and our actual was 110. So if we calculate likelihood between them, we are getting 0.002. Similarly, a third option is 0.5, 1 minus 2. So if we calculate that, it will be 0.85, 0.90 and 0.21. Okay, and what is our actual labels? 110, and if we calculate the likelihood between them, we are getting 0.6129. Similarly for the fourth option also, so we are getting this one, beta values are minus 0.5, 1 2, and if we calculate the p of xi value 0.31, 0.225 and 0.42, and if we calculate the likelihood with respect to labels 1 1 0, we are getting 0.04. So basically we have 4 options and we are getting multiple values. So we have to find what is the highest likelihood, right? So highest likelihood is here 0.61, because you know others are 0.86, 0.08, 0.002, and here also 0.04, and here 0.61, which is the highest. So this option beta is like 0.5, 1 minus 2, this one is the highest option. So this one is the correct answer. Okay, so I have like used the Python function for easier calculation, but you can also do it on your hand using this formula and this formula, previous formula. Okay, so please let me know if you have any questions for this problem. Hello everyone. So hello everyone. So can you please tell me when did I miss? From when I am not audible?
So we were on logistic regression.
Okay. Okay, let me share the screen again. Can you hear me now?
Yes, sir.
Yes, sir.
Okay.
Sir.
Okay. So, are you able to hear this part?
Yes, sir.
Okay.
So you were on formula that P upon 1 minus P. You're talking about the odds.
Yeah, yeah. Okay, okay. So odds is here, right? Okay.
Yeah.
Okay. So basically, here we are taking odds of something like in case of linear regression, we are calculating the value of something, but in case of logistic regression, we are trying to find probability of some class divided by probability of not having that class. So in that case, it will be like probability of pass divided by probability of say fail. Okay. And in this case, suppose if you are taking it here.
Sir, that doubt, can you please clarify? Actually, P of some class means that assumption class or what actually exact class? Can you tell
Yeah,
me?
no. P of so suppose in this case, in the pass fail example, it will be P of passing divided by P of 1 minus P of passing.
P of some class means that any class we can take here, right now, any assumption.
Yeah,
Any number we can take, and based upon that, we have to find out the actual,
yeah,
right now.
but like yeah, you can take, but that will be have to be consistent. Suppose you are picking some class here,
Mhm.
and here also it will be the same class,
Okay, okay. So both the class would be same.
same.
P of some class, whatever I'm taking, that should be same for the P of some class wherever I'm doing the minus.
Yes. So maybe like suppose here I am saying that P of passing divided by 1 minus P of passing. So instead you can do, you can also build a model to predict if someone is failing, right? So P of failing divided by 1 minus P of failing, that you can also do, and here 1 means that he is failing. So you can model in both the ways, but you have to be like maintain consistency. So whatever you are doing, you have to do in all the cases. So then like this is the basically logistic regression
So
format.
you are not audible.
Okay, let me wait a minute. Let me connect. Am I audible now? Am I audible? Hello?
It's audible now, sir.
Okay. So like whatever class you are taking, you have to take like same for this also and this also. Okay. So basically in the logistic regression, we take this log of something, so and equal to beta 0 plus beta 1x. Okay. So what happens here is that in linear regression we try to predict the value of y here. In the logistic regression we try to predict the value of this with the parameters, and then how to find the value of p from this. So this is the basically function from for logistic regression, and then if we take exponential from the both sides, then like exponential of this and exponential of this,
Sir,
then yeah.
so why do we take the log of the odd of P?
Okay, so here you can say this value p divided by 1 minus p, this cannot go below 0, right? Because you know this is also probability, this is also probability. If we divide, both are positive, so if we divide it, the result will also be positive, right?
Yes, sir.
So it will not be, it will not go 0 below 0, but that means we are basically putting a restriction that output is not, cannot go below 0. So that kind of restriction is it will, if we kind of try to apply on the model, it will decrease correlation. So by that we mean that if we, if the model has some restriction, uh, maybe suppose model wants to say predict a value below 0, but it is not able to, right? So in that case it will give 0. But let's say something, let's give an example. Okay, so
So basically, if this p upon 1 minus p, if this happens to be less than somewhere between 0 and 1, then the log value of this p upon 1 minus p would be negative, right?
yes,
So is it somewhat related to that?
yeah, it is somewhat like in this case, if you take log of something, it will be like unrestricted value, right? So there is its restriction is there, it cannot go below 0, but if you take log, it can go below 0. So that is what we have done.
Okay. Like we want, so basically beta naught plus beta 1 x would give the probability of that x belong, the data point belongs to a particular class, right?
Yeah, right,
So the probability cannot be negative.
right,
So the log value has to be positive always.
right. So yeah, in this case, what we are doing is that we are trying to not predict the probability, we are trying to predict the log of the probability. Okay,
Yes, sir.
so maybe in the next slide it will be more clear. So
Okay, sir.
yeah, so basically how to find this, we are trying to find this based on the parameters. We are taking exponential on both the sides. Okay, and exponential and log, they cancel each other. So here only p divided by 1 minus p, and here e power this whole thing, beta 0 plus beta 1x. I hope until this it is very clear. Then if we multiply 1 minus p here, 1 minus p into e to the power beta 0 plus beta 1x. So 1 into e is e, everything is same here. Then minus p into e is minus p, and everything is same here. Okay, then minus p plus beta to the power beta 0 plus beta 1x, we are moving it to the LHS. So it will be like p plus p beta 0 plus beta 1x. So if we take p common, 1 is here, and if we take p common from here, e is here only, right? And beta 0 plus beta 1x is on top, equal to RHS is the same, right? So if we calculate the p value only, it will be e to the power beta 0 plus beta 1x, which was on the RHS, and in the LHS we have this. So if we move it to the RHS, it will be divided, because here it is multiplication. In the RHS it will be division. So it is like 1 plus e to the power beta 0 plus beta 1x. So even though we are taking the log here, but if we transform the equation, then we can find the p value in this way, which will be positive. So then we can further simplify the equation. So e to the power beta 0 plus beta 1x, we can like divide both the both the numerator and denominator by this value, by the e to the power beta 0 plus beta 1x. What will happen? This divided by this, which is same, because of that it will be 1. E to the power beta 0x plus beta 1x divided by e to the power beta 0 plus beta 1x. So same, they will be 1. Then let's focus on this part, e to the power beta 0x beta 0 plus beta 1x divided by e to the power beta 0 plus beta 1x. That is also 1, plus 1 by e to the power beta 0 plus beta 1x. So 1 by something is like it will be just like a minus will come in front, right? So this is the very simplified function. So to find the p, if we use this formula, 1 divided by 1 plus e to the power beta 0 minus then beta 0 plus beta 1x, then we can find the probability instead of like log value. So if even though we are dealing with the log, but if we transform the equation, then we can find it this way. Okay, so if you have any confusion till this part, please let me know. Okay, and these are just some formulas. Okay, so likelihood formula is already given in the lectures. So basically what we do is that we have this one sigmoid function, and then this is theta t xi. This is basically the prediction of the model power. Then we take power y, and then 1 minus prediction we take power 1 minus y. So this is basically the likelihood function, and we can take log likelihood also. Just if we take log on both sides, it will be like this one. Anyway, so I will solve some sample problems which is similar to the assignment. So if you have any questions, please let me know from the assignments. I will from the solutions that I'll be solving. Okay, so at first I will solve this one. So you are given some data points, and you are given the model output here. Okay, p of x, and you are given the level. Okay, and then you have to find the likelihood. How to find the likelihood? uh, you know, this is the formula. So for I equal to 1 to n, so this is basically all the data points. We have to go through all the data points. We have to calculate p power y, then 1 minus p power 1 minus y. Okay, so in case of first point, what is the p? P is 0.1, and what is the y? 0, multiplied by 1 minus p. What is this? 1 minus 0.1, which is 0.9, power 1 minus 0, which is 1. Similarly, for second point, it is 0.8 power yi is this one. So 0.8 power 1 into 0.2 because 1 minus 0.8 is 0.2, power 1 minus 1 is 0. Okay, similarly for this. So if we simplify those, 0.1 power 0 is 1, multiplied by 0.9 is 0.9, similarly 0.8 0.9, and if we multiply those, it will be like 0.648. So this is how we calculate likelihood. So if anything is unclear in this solution, please let me know.
Sir, explain likelihood function.
Okay, likelihood function is given here. So basically we take the product of all the data points. All the data points means here I equal to 1 to n. So here this is I equal to 1, I equal to 2, I equal to 3. So we iterate through all the data points, and we take product of what? P power yi. What is p here? So in case of first point, p is 0.1. So this is basically the prediction from the model. Okay, and y is the level. So p power yi we take here, and then after that we take 1 minus p, which is 1 minus p here is 0.9, right? 1 minus 0.1, which is 0.9. We take power, and then 1 minus yi. So 1 minus yi here is 0. Okay, so 1 minus 1 equal to 0. So here basically we take for we calculate this value for all the points. Okay, and then we multiply them. So that is the likelihood value of the data here.
Okay, sir.
Yeah. The next question is also about likelihood, but the calculation is little bit different, because here we have given p of x, right? But in this case we are not given that. We are given x1 x2, and also here we have to find the p of x, and p of x formula is this one. Okay, so likelihood formula you can just apply this, but you have to find p, and how to find p? With this formula. So for that I have written a Python program for that. So I'll just showing that. So I hope this is visible to everyone. So p of xi we are calculating. How to calculate? We are taking the beta value and we are taking the x value. Here beta 0 plus beta 1 x1 plus beta 2 x2. So here x0 because this is x1, okay, 0 because index starts from 0, and here this is x2, here 1 is written because index starts from 0, so it is like 1. So here we are calculating this value, beta 0 plus beta 1 x1 plus beta 2 x2, this part, okay. After calculating this part, we have to do what? 1 divided by 1 plus e to the power minus that part. So we are also again doing that, 1 divided by 1 plus e to the power minus of that. So this basically calculates, so if we pass something, pass any value to this function, it will just calculate this function, okay, this equation. So let's take an example. So in the data we can see these are the data 0.5 minus 0.4 6 minus 0.6 and 0.8 minus 0.8 and 0.5. These are the values. So we are just taking these values only from whatever is given in the question, and y110 which is given again in the table, okay, 110. So we have written those values only here. Beta value in the first option, what is given? 0.512, 0.512, that is what we have written here, 0.512. We are passing it through calc pxi, which will calculate this equation. So when you have beta value of like 0.512 and we try to calculate the p value, these are the p value, okay. For the first point it is 0.55, 0.47 and then 0.66. So these are the p values for when we have beta values of 0.512. And what is the actual value? Actual value means what is the label? 110. So how to calculate the likelihood? Likelihood function we can calculate here. So y hat means that p and y means the label, okay. So for we are going through all the rows. For every row we take the y hat, which is, we can say p power y into 1 minus p power 1 minus y, okay. So we are multiplying that for all the values and then we are returning it, fine. So for beta values, these three are the predictions and this is the likelihood. Similarly for second option is minus 0.5, minus 1, 2. So for that we have the prediction values this, and if you take the likelihood is 0.002. Similarly for the third option 0.5 minus 0.5, 1, minus 2. So in this case if we calculate the p values are 0.85, 0.90 and 0.21, and if we calculate likelihood, this one is the likelihood. And for the fourth option, likelihood is 0.04. So what do we want? We want the highest likelihood. So in this case the highest likelihood it is like this option, because here it is 0.04, 0.02 and 0.08, but in this case it is 0.61, right. So third option is the highest here, so we'll choose the third option in this case, okay. So is it clear? So basically I have just used like Python here because it is we can say it is easier to calculate because there are multiple beta values here, so you have to calculate multiple times, but you can also do that on pen and paper, and it is actually better to do it in pen and paper because in the exams you will not be able to code. You will be given calculator like on-screen calculator, I guess, but there will not be any option to write a code like this. So yeah, you can do it on pen and paper also. So basically I have also given the the link here for the code. If you want to look out, I'll also share the slides after the session. So in the slides, if you want to look at the codes, you can look, okay. So this is the like likelihood values that you can calculate.
The recording will also be shared.
Yeah, recording. So after the session, I'll share the both the recording as well as the slides PPT.
Yes, sure.
Okay. So are you in the discussion forum? So I am sharing.
Yes.
Okay, I'll sharing that. Okay.
Okay.
So these are the two questions for likelihood. Then let's go to another question. So suppose you are only allowed to use a binary logistic classifier to solve multi-class classification. So multi-class means you have maybe 5 class, 10 class, and you have to pick one of them. And but the catch is you are only used to use binary. Binary means only 2 class will be there. Given a training set with 2 classes, the classifier can learn a model which can be used to classify a new test set point to one of those 2 classes in the training set. So this is basically the same, like you have 2 class, maybe pass fail, or maybe red. You have suppose multiple colors, red, green, blue, yellow, anything, and you are building a model to kind of predict a class, maybe red or blue or anything. Okay, so now the thing is that you have given 6 class, say let's say red, green, blue, yellow, red, green, blue, yellow, black, and white. Okay, and you have to use binary only. So how to do it? Because you have 6 class, and even in binary you can choose between one. You have 2 and you can choose one, but in this case you have 6. You have 6 class. So how to do that? So their solution is that you propose the following scheme. So we will first train a binary logistic classifier for every pair of classes. Every pair of classes means for red and green you are building one classifier, for red and yellow you are building one classifier, red and blue you are building one classifier, red and black, red and white, like that. Then again blue and white, blue and black, blue and yellow, this kind of thing. Okay, so this is like we can say one you will first train a binary logistic classifier for every pair of classes. So for every class you are doing this. Okay, for a new test point you will run through each of these models. So whenever you are getting some point, say suppose you are trying, there is some image and you are trying to predict what color it is. Okay, so basically we have six options and you have to pick between them. Okay, so in that case you have suppose built classifiers, one for picking. So given an image you will pick if it is yellow or green, and given an image you will pick if it is yellow or black, like that. Okay, and for a new test set, suppose you are given a new image, you will run it through each of these models. So you will give the new image to all the models, and which class wins the maximum number of PROs contest. So like suppose yellow is the maximum winner on those, that will be like I'll say that yeah, that is the yellow, if yellow is the maximum among all those. So the question is how many logistic classifiers you need to solve the problem. So basically this can be solved by 6 C2. So 6 is the number of classes available, and from each we are taking 2 values, right? So each classifier can distinguish between 2 values because it is binary. So 6 combination 2, which is 6 factorial, then 4 factorial multiplied by 4 here 2 factorial and 6 minus 2, which is 4 factorial. So that is 6 into 5 divided by 2, which is 15 classifiers you need to train. So if it is not intuitive, I can also show by some example. Okay, let's consider this. You have red, green, blue, yellow, black, and white, and you have to build classifier for all of this, all of pairs. Okay, so So basically you have to do pairwise thing. So everything will be need to be compared against everything. So red versus green, you need to do one classifier. Red versus blue, you need to do. Red versus yellow, you need to do. Red versus black, then red versus white. So red is complete. Then again you have to do green versus blue, green versus yellow, green versus black, green versus white. So this kind of thing. So for red you have to take for 5 this, compare against this. For green you have already compared with red, so you have to compare with all 4. Blue, in the previous step we have already done red and blue, so and red and green and blue, so you have to again calculate for this like that. So if you take all of them, what you need to do, it will be 15 different classifiers. Okay, so this is the question here. Then okay, so then we'll move to the next question, which is about LDA. So
Sir,
yeah,
so in the previous question,
yeah,
we have some data point and we have to label it among the all the 6 colors, like any one of the 6 colors, right?
yes, anyone.
So the question is exactly what does it ask is we have to construct a binary classifier
Yeah,
that classifies each data point into 2 categories.
yes. So
So the any data point might be corresponding to say it's yellow, and we have construct a binary classifier which classifies the data point into black and white.
mhm,
So neither of black and white comes to be true.
yes.
So how will it classify the
So
data point?
yeah, so in that case, you know, it is classified to do say black and white, and your point is yellow. So it will classify into something, either black or yellow, like either black and white. So suppose you are building a classifier, let's say something, say cat and dog, cat and dog suppose, and you are giving an image of a human, it will say something, it will say either cat or dog. It will be wrong of course, but it will say something. Similarly here also, if you take say yellow color, if you take yellow color and if you give it to binary classifier with black and white, it will provide some value that it is black or if it is white. It is wrong, but it will give some value.
So based on the familiarity or the likelihood.
Yes. So maybe
Okay.
white is just plain, and maybe if you take grayscale, maybe yellow will be kind of like gray, so that may be kind of like black, that kind of thing can be there.
Okay,
So
sir.
yeah, underlying things, it can be many things, but you will get some a label, that is the main point.
Yes.
Yeah. So this is from practice assignment. Okay, so you are given a 3D input data, 3D because you know there are 3 values, suppose x1, x2, x3. Okay, and you have to identify the principal component. So steps are given. At first step is enter the data, and then calculate the sample covariance matrix and calculate the eigenvalue and eigenvector, and then identify the principal component. So these are the steps. So I'll go through all this step by step. So at first center the data. To center the data, what do we need to do? We need to find the mean at first, and then we need to subtract every value from the mean. So if we take the column wise mean 1, 2, 3, 4, 5, the summation is 15, and if we take average, it is 3. Here the summation is 11 plus 9 is 20, 20 plus 7 27, 27 plus 4 31, plus 1 32. 32 divided by 5 is 6.4. Here also 9 plus 6 15, 15 plus 4 19, 19 plus 4 23, 23 plus 2 25. 25 divided by 5 is 5. Okay. So basically in each column we will divide it like we will subtract the mean. So 1 minus 3 is minus 2, 2 minus 3 is minus 1, 3 minus 3 is 0, 4 minus 3 is 1, 5 minus 3 is 2. Similarly, we will do for this also. 1 minus 6.4 is minus 1.54, like this. Same for this row also. 4 minus 5 we got 4, and 6 minus 5 we got 1, like this. Okay. So first step is done. We are calculating the mean, and then we are subtracting the mean from every column. Okay. Then we have to find sample covariance matrix. So sample covariance matrix formula to calculate, we have to use this one, x minus mu prime. So this is basically transpose actually, multiplied by x minus mu and divided by n minus 1. Okay. So let's find this one, x minus mu. We have calculated this. So from this we have already subtracted the mu, right? So this one is now x minus mu. Okay. So x minus mu transpose is this. So this one is x minus mu, and if we take the transpose value, we are getting this. Minus 2 is there, suppose minus 5 minus 5.4 here, 4 here, then minus 1, minus 1 here, minus 2.4 here. Okay, it should be minus 2.4. Okay, something it is like written wrong, but it should be like a minus 2.4 anyway, and then it is like 1. Okay. So if we multiply them, then we will get this value. Okay. So let's take this side, this value, 2 into 2. So matrix multiplication, if we do minus 2 into minus 2 is 4, minus 1 is 1, so 4 plus 1 5, then 5 plus 0 into 0 is 0, 1 into 1 is 1, so 5 plus 1 6, and 2 into 2 is 4, so 6 plus 4 is 10. So for this one we are getting value 10. We have to divide it by n minus 1, so n is equal to here 5. You have 5 data points, so n minus 1 is 4, so here we are getting value 10. 10 divided by 4 is 2.5. Okay. So that is we have to calculate. Okay. Then next step, we have calculated the covariance matrix, which is here. So if we just take the matrix product here, we will get this value, this matrix. So after calculating this, we have to calculate the eigenvalue and eigenvector. So this is basically a large matrix, and how to calculate the eigenvalue, eigenvector, you can calculate on your hand. You can also calculate using using a program. So I have written a program to find it quickly. Okay. So in this case, we are using okay, the program is opening. Yeah. So we have the, again you are using the NumPy library. Okay. Then we are declaring an array, and we are giving the values here. So what are the values? 2.5 and minus, so here 2.5 and 5.75 and minus 4. Okay. And then other two also we are giving it here. Fine. So this is the our covariance matrix. Okay. And from that, how to find the eigenvalue and eigenvector, we can just call np dot linear algebra dot eig. So this is for eigenvalue and eigenvector, and we are passing the matrix, and then we will get this one, eigenvalue. Okay. Eigenvalue is 23.92, and this one 0.1298, and then 1.24. Okay. So this is the eigenvalue, and this one is the corresponding eigenvector. So this is the first eigenvector, second eigenvector, third eigenvector. Okay. So in this case, I think, yeah, there will be minus 0.24 here. Okay, so you need to adjust the calculation accordingly. So maybe let's do it here only. Okay, we need to adjust a calculation for this row, right? Okay, so let's open the calculator and let calculate live. So for the second row we have to calculate everything. Minus 54 into minus yeah. So let me do one thing, let me share the whole screen and use the system calculator. So is it visible? Okay. I will open the calculator. Okay, so first one is correct, I have like already calculated that. Second one we need to find out the values for the second, because by mistake it was kind of a it was mine, yeah, it was by mistake it was I have written 2.4, but it is actually minus 2.4. So suppose we are calculating this, how to calculate it? Minus 5.4 into this one minus 2 plus minus 2.4 into minus 1. Please let me know if I am doing any mistake on the multiplication. So this is 0.6 into 0 is 0, then 4.6 into 1, then 2.6 into 2. Okay, it's 23 divided by 4, so this is 5.75. so this one is correct. Same for the next one. So minus 5.4 into minus 5.4 plus minus 2.4 into minus 2.4 plus 0.6 into 0.6 so 15.8. Okay, so everything is coming correct. So apparently I haven't given the minus here, but calculation was right. Okay, so this one is right. Fine, then covariance matrix is formed, so we'll move to the next step. I'm sharing the screen again. Okay, so covariance matrix we got here. After that we have to calculate the eigenvalue and eigenvector. So we have already calculated from here. Okay, eigenvalues are these three, and eigenvector is like this one, and this one. First eigenvector, second, third. So what do we need to do here is that eigenvalue and eigenvectors are calculated here, and then we need to identify the principal component. What is the principal component here? So here which eigenvalue is the highest? This one, right? This one is the highest, and so the corresponding eigenvector is the eigenvector, okay, the principal component. So here what are the eigenvectors? 0.3104, 0.80 and minus 0.5112. Okay, so these are the eigenvector. So in the option, if we go here in the option, that particular option is not there. So yeah, this is from the practice assignment, and say we are getting this value 0.31, 0.80 and minus 0.51. So that option is not there, but this one is there. So which is basically minus of something. Just if we multiply this row, this column by minus 1, it will be minus 0.31, minus 0.80 and plus 0.51. So that is there, and this is the correct option, because we can multiply the eigenvector by any scalar value, and minus 1 is scalar value. So this is a correct option. All right. So this is how you find the principal component with LDA. Then next question is very similar to this. So in this case, so we have already found the any question?
So, excuse me, sir. How to calculate by calculator? You have used the Python code, but in exam we have to use the calculator. So how to calculate how to calculate the eigenvectors and eigenvalue using calculator in the exam?
Okay, so eigenvector, I think it is covered in week 0. You can find it from there. So this is part of linear algebra. So given a matrix, so you don't need to consider this. You just consider this as a matrix, okay, and you have to calculate the eigenvalue and eigenvector of this matrix. So you can do it on your hand by formula. So it is like and I'll show the formula also. Yeah, so this is the formula actually. So A minus lambda I x equal to 0. So A is the matrix, lambda is the eigenvalue, and I is the identity matrix, and x is the eigenvector. So maybe I think it is covered in week 0. You can find how to calculate eigenvalue and eigenvector. If not, you can find some resource online. So I think this is also covered in high school, but for larger matrix it may take much longer time to calculate. But the basic things, you have to take determinant, and then you have to solve for those. So maybe also you can refer to that book. So pattern recognition and machine learning by Bishop, so which is the recommended book for this course. So you can also refer to that. So next question is, so we have already got that data point, the eigenvector here, principal component. So in this case they are saying that we have got the principal component and we want to transform the data to the principal component. Okay, so and instead of one principal component, so in those course in the previous one we have considered that highest principal component, right, 23.92, which is highest. So we are taking this one, this first column. But in this case it is saying that no, you take the second one also, first two principal components, like most positive. So in this case, what is the second highest? This one, right? So this one is the second principal component. So first principal component we have already found it, we have written it here, okay, and second principal component we'll just copy from there 0.2617, so 0.2617 .58917644. So this is kind of rounded off, so this is like the sum. Okay, then we have to again do a matrix multiplication. We can also do it via, we can say by hand, like this into this in plus this into this plus this into this, so that might be very time consuming for these fractional numbers. So I have written a code to do it correctly, will do it quickly. So again this one is the matrix. What is the so whenever you are transforming to a principal component, you have to take this data, after centering. So after centering the data is this, so you have to transform this data, not the original matrix. Okay, so I am taking the centered data, then we are multiplying by the first eigenvector, then and second eigenvector. Okay, so this is the thing. First eigenvector, this is the matrix, first eigenvector, second eigenvector, then we are just multiplying it np.matmul, which is kind of say used for matrix multiplication. So after matrix multiplication we are getting this 6.9934, this one. So this is the result. Okay, and this is the result after transforming into first two principal component. And if we see the options, 6.9935, 0.4003, 0.400, this is kind of near to 3 if we round off. So this one is the option, correct option. So if you have any confusions for any of the questions, please let me know. Is this only for sigmoid for blue? So blue, which one is incorrect? Can you please clarify? For exam, how to calculate p of x? Yeah, you can use this formula to calculate p of x. Yeah, by calculator you can use this formula only. Okay, for p of x, and for eigenvector you have to look at 2x0. There they have I think detailed explanation how to calculate those. So these are all the questions numerical related that will help you to solve the assignments. I will not be discussing the conceptual questions because you should watch the lectures and try to solve the conceptual questions on your own. But the numerical questions, I think if you follow these examples, yeah, the number of data points are different and maybe somewhere, but otherwise I think they are very similar to those assignment. So if you understand this, I think it will be very easy for you to solve the assignment questions. So again, if you have any questions or any confusion among these, please feel free to ask. Our discussion forum link. Okay. So if you want to join discussion forum, okay, so do one thing, go to the NPTEL portal and then click on ask a question. Okay, So then you will get a prompt like this, click continue, and then I think you will get some form to provide some information. I am not taking that because I have already joined. So after filling that, you will get there, and you can ask any question here. And then also anything, any assignment, like any the lecture recordings and everything, I'll share on this. So if you join here, you will get a email for whatever whatever recording we are providing. So you can join here, but I don't think you can join directly by this link. So you can join by clicking there, clicking on asking the question.
Okay, sure, sir.
PCA and logistic regression, you can follow scikit-learn. Okay, sklearn. Yeah.
So, sir, these video and all are available on discussion forum or on Drive, sir?
Right now it is not available. So after the recording is over, so
Yes,
after
sir.
that I'll upload it on YouTube, and then I'll send the link to the discussion forum.
Okay.
You have considered the eigenvector for the first principal component as negative and eigenvector of second principal component as what you get in the result. Okay, does the negation of the second eigenvector matter in terms of result? Not really. So here, let me show here. In this case, I have taken the negative of the eigenvalue here and actual eigenvalue here. So as long as I am doing the same for all the data, it doesn't matter. Okay, suppose there is a new data point. Suppose this is the data point right now, and we are inserting a data point, say 3, 1, and maybe -2. So this is suppose the test point, okay, or anything. Okay, so as long as I am transforming this using the same, it is fine. We cannot do like a positive eigenvector for this row, negative for that row. We cannot do that. As long as like we are using this transformation function, it is fine. Positive or negative, it is okay. LDA, I think there are 3 lectures on LDA, so I guess that should be clear from there. But like anything specific you have in your mind regarding LDA? Okay, so you can do one thing. I was looking at some blogs regarding LDA, so not this. Yeah, this one. So you can follow from here. But I think like LDA should be much clear from the lectures, because you know there are 3 lectures for that, very good ones. So if you have any specific part that you don't understand, you can always tell me.
Hello, sir.
Yeah.
Sir, can you please explain that week 3 question number 5 for quiz session? Just explanation for understanding the question. Can you please tell?
Okay, for like week 3 question 5.
Ah, uh, quiz.
Okay.
Question number 5. Yes, sir.
Okay, so we have a classifier and we have 3 class classification. So maybe consider win, lose, draw, that kind of thing, or maybe yeah, that kind of thing. The following tables give condition density of 3 classes, k equal to 1 2 3 at some point, and then put space. Okay.
Sir, that 3 class classification is mentioned, that for that 3 class here they mentioned the k equal to 1 to 3, right now?
Yes.
Okay, okay.
So this one is kind of say level 1 2 3.
Okay, can you explain this question, sir, properly, like with some derivation, not the, you don't tell the answer, but just for justification, can you tell?
So this gives class condition density of 3 classes, k equal to 1 to 3 at point x. Okay, and then fkx. Fkx means the probability of class 1 at point x. Okay, so this is like at point x, the probability of class equal to 1 is 0.15, probability of class equal to 2 is 0.20, and probability of class equal to 3 is 0.05. Okay, pi k denotes the prior probability and of class k, which is the following statement are which of the following statements about the predicted level at x are true. Okay, so you are given this table, which is indicating that probability of class k at point x, and then you have at the weighted level you have to find which of them are true, where pi k denotes the prior probability. Okay, if 3 classes have equal priors, the prediction must be class 2. So that means suppose you have class 1 2 3, and if pi k value is same for both all the classes, okay, then the label is 2, k equal to 2. So maybe pi k.
Sir, if it is for the all the classes means the option should be there now 1 2 3, but here only based upon 2 2 and 1 3 and 1 is mentioned, not for the 3 class. That's what the confusion is coming.
Yeah, so that is you have to decide, right? So is it true or is it false? You have to kind of decide that.
But it should be based upon that k value now 1 2 and 3. That class should be based upon 1 2 3. But here in all the option there is not all the values are present now 1 2 and 3. Somewhere it is 2 class 1 and 3 and 1.
Yeah, so one thing is written here is that like they have equal priors, okay, here. So what will happen if there is equal prior? You have to decide that.
Yes, sir, got it.
Similarly, like there are other thing also. So these are the some conditions you have to decide based on that. So yeah, do you have any confusions from previous two weekly assignments? So week 1 and week 2, I guess your evaluation is over. So if you have any confusions from those, you can ask me.
Sir, in one question, whether between KNN and linear regressor, one question is there that whether training set is needed, true and false only statements we need to give. So linear regressor, it has given only KNN needs training set. Linear regressor also needs training set. No, sir?
Okay, can you show me the question number?
Yeah, question number. It's week 1.
7.
No, sir. Yes, sir. Week 1, 7th question, yes, sir.
Okay, so there are 4 options. Linear regression requires the training data points during inference. Then a KNN requires training data points for inference. Okay, so in the linear regression, what we do, suppose if you go to the previous week slides, wait a minute, I'll just
Yes.
so in the linear regression, what happens, you train the model, okay, and
Yes.
you obtain the beta value, and like beta was 0, beta 1, beta 2, whatever.
Yes.
But after that you can throw away the data. If you have the beta value, then you can
Yes,
make
sir.
prediction, right?
Yes, sir. Yes, sir.
So here the catch is, it is written that during inference.
Okay.
So during testing you don't need the data, training data, you just need the beta values.
Okay. Yeah.
But
Yes.
in the
Got
KNN you have to find the neighbors, right, where the nearest point is. So that time you need the data.
Yes, sir. Understood. And sir, next question also, sir, this 8th one. So that answer is 0, 100, 1.
Yeah,
So
so
it is based on actual and true. Yes.
I'll discuss that also.
Yes.
So this is week 2. Okay, so you have to build a kind of say a matrix Okay,
Yes, sir.
so here it is saying so you can see if we consider that actual is below, like this one are actual and this one is the prediction, so this will be a kind of a confusion matrix. So in this case let's go to the question. In this case, consider a binary classification problem where we are giving something anything. Okay, so the thing is in this problem false negatives have more serious consequence. So if you say that the person is healthy
Yes, sir.
but actually the person is not healthy, which
Yes.
is false negative, so that has very severe consequences, because the person will think, yeah, I am healthy, and he will not do any treatment. So that is very dangerous. False positive, which means I am saying that person is unhealthy but actually the person is healthy. So in that case it is a little bit dangerous, but not that much, because maybe a doctor will do more tests and find out if it is actually healthy or not. So
Yes.
that is less dangerous. So thing is that this should have more number than this false positive. False negative should have higher priority. So we can say, if we take here this is false negative, okay, so this should have say 100, and this
Yes.
should have say 1, and true positive is 0, because uh, this is not dangerous at all, we are just telling the true thing. Okay,
Yes,
so this is considering actual is below and prediction is on the right. But what is here in the question? In the question it is written that row denotes true class and column denotes predicted class.
Row did not. Oh, okay. Yes,
Yeah,
it is opposite.
opposite.
Yeah.
Yeah,
Okay.
yeah. So it will
Got
be
it.
Sir,
like
how that false negative you're taking as 100?
so 100 is just we can say a arbitrary value. So basic point here is that uh, this one false negative should be more than false positive. So you can say here like 1, it is 2, it is also fine. Maybe we can say here a 5, 20, fine. So by giving 1 and 100, we are saying that false negative is 100, like 100 times more dangerous than false positive. That's it.
Sir, sir, but in this case also, actual is row. No? Means what example you have shown.
The row denotes true class and column denotes weighted class. Wait a minute.
So here also rows are actual and predicted is column.
ಯಾರಿಚ್ಚಾರೆ
No, no. So in that case, row. So this is the row. It is saying row is the prediction. Row is the actual, right? Row is a true class. Yeah. Here,
Yes,
this is
sir.
the row.
Yes, sir.
Row, this is true here, and this is the prediction. But in our case, it is prediction is this one.
Okay. Prediction is this.
So
Okay. Column is in this case actual is column.
yeah,
Okay.
so
Okay.
let's do for that. Let's copy this and do it for this one. So so in that case, it will be like pass maybe here. This one is will be true class. It is row, right? So this right side is true. And actual is actual bottom, like column is prediction.
Predicted. Okay.
So in that case, it will be false positive.
Yes, sir.
This one false
Yes,
negative.
sir.
Yeah.
Yes. Got it. Thank you.
Week 1 9th question. how to solve 9th question in assignment 1. Okay. Okay. So we have this data and our point is 0.7 and minus 0.8. So we have to find the nearest points. Okay, let's take this image. Our point, what is needed here is minus 0.7 and okay, this one is the point. So we have to find what is the distance of 0.0708 with respect to this x1, x2. So for the first one, we have to calculate what? Square root of this minus this whole square plus this minus this whole square. So minus 0.5 minus 0.7, yeah, whole square plus 0 minus minus plus, so it is 0.8 whole square, right? So this is the distance for
First
plus.
one is, sir,
Yeah.
the first one is 0.5 minus 0.7,
Yeah,
not 0.07.
right. So what will be the value here? Let's say
Not 1.44.
so. Let's use some online calculator to do it quickly. Because we need to do it for multiple points, for 6 points actually. Yeah. So first point here is maybe 0.7 minus 0.8, 0.7 minus 0.8, and second point is minus 0.5 and 0, 0, like minus 0.5 and 0. So this is the distance, okay, 1.4222.
Yeah, I got that.
So same we have to repeat for others. Second, we have to do the same, and if we do 2.0, 0.5, distance is this one. Third point, minus 1 minus 0.5, minus 1 minus 0.5, this is the distance. Fourth, 0 minus 2, fifth point 2.5 minus 1.5, sixth point 1, 2. So these are okay. So the question is what of the points are
Sir,
nearest. Yeah.
sir, can we take the difference of 0.7 minus 0.5?
Yeah, yeah. Anything is fine because
That
either way is fine. Result will be the same.
same. Both are same.
Yeah. So just do it here. 0.7 minus minus 0.5 minus minus 0.5 means plus. So it will be like 1.2 square. It is also minus 1.2 square. So if you take square, both will be the same. So you can take it either way. We are taking here minus 1.2 whole square, and in the if we do it opposite it will be like 1.2 whole square, but result will be the same because minus minus square it will be always positive. So in this case we are told that we need to take at nearest 3 points. So what are the distance lowest? This one,
1.39,
yeah, this one is lowest distance, then
1.44,
yeah, and
and 1.73.
yeah. So what are the labels? It is 0 here, third is 1, fourth is also 1. So 0 1 1, which one is highest, like which one is occurring more times? 1. So 1 is the answer.
So we need not take the average.
No, so because it is classification, right? So we have to,
Okay.
Sir, sir, 1 minute, sir.
yeah,
Go back to that slide.
yeah.
Sir, here you see 1.83 and 1.72 and 1.93. These are also closest.
We have to take the lowest distance. So from,
Okay, first we have to take the lowest and then the corresponding the nearest one. That is the way.
no, like we are calculating distance from this point, okay? So
Mm-hmm.
we are calculating this. So at first you have to take which one is the lowest. This one is the lowest. Okay. Sorry,
That's it.
this one is the lowest. Then we have to
Oh,
take which one is second lowest. This one is the second lowest.
okay, okay,
Third lowest is
okay,
this one. Yeah,
okay. First up, we have to the minimum one, which
minimum.
one the minimum.
Then
Okay,
second minimum, third
got.
minimum, because k equal to
Okay,
3.
okay, good.
Yeah. So any assignment 2 questions, if you have any issue, you can tell me, because like this similar kind of things might come in the exams also.
Hello, sir.
Yeah.
Sir, week 2, question number 3, can you explain how it is 60.8?
Week 2, question number 3. Okay. So correlation between studying time. So someone is studying and grade is between 0 to 100. So this is the formula 30.5 plus 15.2. So suppose a student is not studying at all compared to not studying. So suppose he is not studying, okay. So what will be his score? 30.5 plus, okay, 30.5 plus 12.5 into h. I guess that is the formula. 15.2 into h. Okay. So suppose someone is not studying, means h equal to 0, haven't even studied 1 hour. So in that case 30.5 plus 15.2 into 0, which is 30.5. Okay. Studying,
Sir, why into 0? Rather, that hour is mentioned na, in the question. 4 hour they mentioned.
yeah, I will also
Studying 4 hour.
studying 4 hour is h equal to 4, right? So that is 30.5 plus 15.2 into 4. So what will be that? 30.5 plus 60.8, right? Equal to
Yes.
91.3. So the question is how much more marks we will get. So how will students get to be affected if he studies by 4 hours compared to not studying? So how much more marks you will get by studying 4 hours? So that is 91.3 minus, if you didn't study, then also you are getting 30 marks, 31.5 marks. So that is 60.8.
Okay, sir. Got it, sir.
Okay.
Sir, 7th question.
We-
Second assignment, 7th question.
Okay.
7th.
Okay. So when working with some small data set, one should prefer low bias, high variance classifiers over high bias, low variance classifiers. Okay, let me check all the options. When small data set, okay, at first let's go for the small. So their conclusion, high for small data set we should take high bias, low variance, right? And for large we take low bias, high variance. So why is that? So for small data set, when you have say suppose very few samples, in that case you should prefer high bias. So if you have very small data set and if the variance is high, then what will happen is that it will get overfitted. Like I can say outliers will affect them by very much. But in case of large data set, that issue is not there. So in that case you can use low bias, high variance. So actually there is a we can say there is a official solution for this question. I will show that to you just now. I guess no, it is not there. I guess, yeah, it is there. Okay, answer is not there. It's fine. So basically, whenever we are working with small, so I think this is covered in the lecture also. So uh, when we have a small data set, we want to keep the bias as low as possible and high variance, such that we should keep bias as high as we can, but not like that, but like if we have two options, like one has high bias and another has low bias, and one has low variance, another has high variance, between them we can choose this one, like high bias, low variance, because you know if we have high bias, low variance, then our predictions will be much better in case of like low data set with small size, because like if we have low bias, high variance, in that case so if we change the data size, suppose high variance means if you change the data split depending upon how you are dividing the trend split, validation split and test split, the performance will vary by very large amount. So suppose if we take first 60 examples for training, then 20 for validation, then 20 for testing, and that is another one experiment. And another one is that you take the last 60 for training, then first 20 for testing and first 20 middle 20 for validation. And in case of low bias, high variance, because of high variance the performance will vary by large amount, because depending upon variance of the data the training will be different. But in case of large data set, you can a large data set contains very I can say diverse set of examples that you can expect. So if we have maybe 1 million size data, it will have examples from many, like many categories, many kind of things will be there. So in that case, it doesn't matter like from where we take, from where we sample the data, it will be like even if it is high variance, it will be like even if it is like high variance, then also it is fine, because the data set is like that only. Everything from wherever we take, it will be diverse in case of large data set. So that is the reason. Haritha, yeah, you can speak. You can unmute yourself.
So can you explain week 1, 10th question?
Okay, you can go. Okay, so you have two models. Okay, one is beta 0 plus beta 1 xi x1 plus beta 2 x2. So this is a simpler model compared to this one. This one has an additional parameter beta 3, and we are giving x1 x2, which is just a multiplication of like these two, right? These two inputs. So this one equation 3 is more complex than equation 1. So depending upon that what will be the options on a given training data set, the mean square error of 1 is always greater than equal to that of 2. Yeah, because this one has more parameters, right? Beta 3. This one is more complex, so it is expected that this will give a better prediction, like it will be able to fit the data more appropriately than this one. So yeah, this may overfit, that is a different thing. But suppose you have a data, let's say maybe this one. Okay, you have this, and if you use this model with this one, we have 3 parameters, beta 0, beta 1, beta 2. So it may or may not fit, but if you say beta 0 plus beta 1 beta 2 is there, also you are giving another beta 3, another parameter, and also you are giving the multiplication of these two, so it is much more likely to be kind of fit. So as this model is more complex compared to this one, so this is more likely to fit the training data. Doesn't matter what will happen for test data, but training data, it is much more likely to fit. And in that case, if it is fitting better way, that means the error will be lower, right? So mean square error of 1 will be lower here, so higher here, lower here. So that one is correct, first one is correct. Then this one is between these two, which one is likely, which one which of these two models are likely to have more variance. So more variance means, suppose if we give first 4 data in the training, or if we give last 4 data in the training, the loss function might drastically change the mean square error value. So that can happen in this case. Second case, it is more likely, because it is more complex and it will be able to fit the training data more better way, right? So if that happens, that means if we change the training data, that can drastically affect this model, but not that much for this one. So that means the variance is higher in second. And similarly, this one, if this one underfits the data, then this will also underfit, because this one is much more complex model. If this model is unable to fit the model, then this one has no chance almost, because this one has this is more complex and has more parameters. So this is the kind of the explanation for this.
How about the answer? Third answer, if
Which one?
option two is overfits, then definitely the model one also overfits. Yeah.
Okay, so
How this won't be applicable? Okay.
so this one is more complex, right? So suppose if we can map input to output with the beta 1 beta 0 beta 0 beta 1 beta 2 beta 4 with this function, so that means uh, it doesn't mean that this will be able to do it, because it is much more simpler than this one, but reverse is true. So suppose this is overfitting, then it is more complex than this one is more complex than this, then that definitely means that this will also overfit. But because this is simpler, that means even if that overfits, as it has lower parameter, it may not overfit. So it is, we cannot say definitely it will overfit, because it is less complex and it is has less number of parameters. So I think similar things have been covered in lectures also. So the basic thing is that complex models. So suppose you can think that if I build a very big model, then I will get very good results, but that is not always the case. What can happen? The model might memorize 0.5 and minus 0.5 and 0 is 0, and 2.0 and 0.5 is 0. So model will be able to memorize this, but what if we give minus 0.400, it will not be able to do it correctly, because model has learned to predict on this data only. So if you give something outside of this data, it will not be able to, and this happens because model is too powerful to memorize this data. But in case of here, model is less powerful than this one, right? So this parameter is absent, x1 x2 value is not here to the model. So model here may overfit, may not overfit. But this, if this is overfitting, first one is overfitting, then we can definitely say second one is also overfit, because here suppose this is the model, and in the second case this is only this one is just the part of this one, right? So we have additional parameter of this. So if this portion is itself overfitting, if we add anything more, then this will also overfit, but reverse is not the case. So here this parameter was there, but here this parameter is not there. So it is possible that it was fitting because of this additional headaches, these things, but it is not there. So you cannot say for sure that it will overfit. But in case of underfitting, that means it is not fitting properly. The training set itself we are not able to generalize. So in that case, if it is underfitting, so if it is not able to map from input to the output from the training data itself, we can definitely say this will also be not able to do, because this is you can say this part is not as complex as this. So you can think like it is kind of like saying if say Usain Bolt is not able to score maybe complete a race within 10 meter, like 10 seconds, then I will also not be able to do it, because he is kind of like Usain Bolt, and it is like a normal person, this kind of thing, because this is much more complex. You can think it like this way.
Thank you, sir.
Yeah. So any more questions? Then maybe I will end the session. Thank you everyone for joining.
Will a recording of the session be available on the website?
Yeah, recording I will give on the discussion forum. So have you joined the discussion forum?
No, I haven't.
Okay, so you can do one thing. Go to the NPTEL, okay, and go to the ask a questions. Then you will get a pop-up like that, and just click on continue, and then you will get something here. Okay. So
will it be available soon after this session, or
yeah, maybe 1 2 hour, within 1 2 hour it will be available.
Okay.
Yeah.
Thank you.
Thank you for joining.